All right, this is the backside of the Bellwork that we're calling, well, we're calling it Bellwork 8.6 ABC Bubbas truck. Number 5 says a force of 100 newtons is applied to different blocks. Calculate the acceleration for each block, and in general, how does mass affect acceleration when the amount of force doesn't change? Okay, so the force is going to be the same for each one of these situations. And we're going to assume that that's net force, obviously. So we need a formula to calculate acceleration when we know net force and when we know mass. So we're going to use acceleration is equal to net force divided by mass. For the 1 kilogram object, we're going to say the acceleration is 100 newtons, so that's the net force, divided by 1 kilogram, which is the mass. 100 divided by 1 is an acceleration of 100 meters per second squared. Okay? All right, so that's going to go with that one. Then we have a mass of 10 kilograms. And again, acceleration is net force divided by mass. Net force is still 100 newtons. The mass this time is 10 kilograms. 100 divided by 10 is the same as 10 divided by 1. And that's going to give us an acceleration of 10 meters per second squared. Then we have a 25 kilogram mass. Again, the net force is the same, 100 newtons. The mass is 25 kilograms. Acceleration is net force divided by mass. And this time you get 4 meters per second squared. And I'm going to say meters per second squared because really a newton is defined as the force required to accelerate a 1 kilogram object by 1 meter per second squared. So a newton is equivalent to kilogram meter per second squared. And if you think of it that way, the kilograms would cancel. So up here, 25 kilogram mass. We're going to get an acceleration of 4 meters per second squared. And then finally, if we have a 50 kilogram mass, again, acceleration is equal to the net force, 100 newtons, divided by the mass, 50 kilograms. That's going to give us an acceleration of 2 meters per second squared. Okay? So let's answer this now. In general, how does mass affect acceleration when the amount of force doesn't change? Okay, so the amount of force is not changing. But as the mass gets bigger, so as mass gets bigger, the acceleration is going to get smaller. Okay, and that's basically what you need to write. Okay, so the answer, it's kind of jumbled up, but how does mass affect acceleration as long as we don't change the force? Well, when mass goes up, acceleration is going to decrease, meaning it's going to accelerate less. Okay, so now we're going to move down and talk about this box. Number 6 says you've got a box that has a mass of 2 kilograms, and there are 2 forces acting on the box. One of them is over here, one of them's over here. But the big thing that you need to notice is that maybe this one is a push force, but it's oriented or pointing to the right. This one might be like a pull force, but it's also oriented toward the right. So the 2 forces are pointing in the same direction. And if the 2 forces are pointing in the same direction, I'm going to add them together. So the net force on this box is actually 14 newtons. Okay, so there's my net force, 14 newtons to the right. Again, it doesn't matter that one's on this side of the box and one's on that side. It matters that they're both pointing in the same direction. Okay, next one, does the box accelerate? Well, the box is going to accelerate anytime there is an unbalanced force acting on it, or meaning the box is going to accelerate anytime there is a net force on it that is not equal to 0. So do we have a net force that's not equal to 0? Yes, we do, because the net force is 14. So does the box accelerate? Yes. If yes, which way? Well, the box is always going to accelerate in the direction of the net force. The net force is to the right, so the acceleration will be oriented to the right. And how much the box accelerates is going to be dependent on not only the net force, but also on the mass. Okay, so there's my formula. Acceleration is net force divided by mass. The net force we got up here, so 14 newtons. Looking at the box's mass is 2 kilograms. 14 divided by 2 is 7. And again, if you'll think of newtons really as kilograms times meters per second squared, then the kilograms cancel and you're left with meters per second squared. So it accelerates at a rate of 7 meters per second squared. It's going to accelerate to the right because that's the direction of the net force. Okay, and then we have our lovely little skydiver. A skydiver with a weight of 1,000 newtons opens his parachute, creating a force on the skydiver from air resistance, which is a type of friction. The force from air resistance, is 4,000 newtons. So first of all, let's kind of draw what our situation is. His weight is 1,000 newtons. And his weight acts down because it's weight is the force of gravity due to the gravitational interaction between you and the Earth. And then when he pulls his chute, the parachute acts as like a big old air catcher. So the force of air resistance, when he pulls his chute open, is 4,000 newtons up. So what is the net force? The net force, you're going to look at both of these forces. You have 1,000 newtons down, you have 4,000 newtons up. The net force is going to be 3,000 newtons up. You're going to subtract because the two forces are pointing in the opposite direction. And then the net force is going to take the direction of the bigger force. The bigger force points up, so the net force points up. Is he accelerating? Yes, because there is a net force acting on him. And the net force is acting up. His acceleration will be oriented up as well. Okay? All right, now it says to describe the skydiver's motion. Notice I did not have you calculate his acceleration. The reason why you can't calculate his acceleration is because you don't actually know his mass. Okay? Now, I would like you guys to go back and think about the truck situation from lesson 1. Let me find that. Okay, this is something that you drew on page 182 in Unit 4, Lesson 1. And let's say you had a truck and it was moving along at a velocity of 25 meters per second. and then you hit the gas. Well, that means that the acceleration is going to be oriented in the same direction with the velocity. And because those two are both pointing in the same direction, it's got like a cumulative effect. It's going to make the truck speed up. It's going to make the velocity increase. But in another situation, let's say that the truck was moving to the right at a velocity of 25 meters per second, and you hit the brakes. Well, that means that the acceleration is oriented against the direction of motion. And so those two things are going to work against each other, and the truck is going to slow down. It doesn't mean that the truck is all of a sudden moving to the left. It just means that the acceleration is working against the velocity because the brakes, he hit the brakes. So that's basically the situation when the skydiver pulls his parachute. The skydiver pulls the parachute to slow himself down. He doesn't want to hit the ground at 100 and something miles an hour. So he's going to pull his chute, and pulling his parachute acts like hitting the brakes in the truck. Okay? So describe the skydiver's motion. The skydiver slows down when the chute opens. However, the skydiver is still falling. And part of the reason why people get confused is if you've ever seen footage of a skydiver, a lot of times the person filming the skydiver is another skydiver. And when the guy that's filming, he's sitting there with the camera on the other guy, and the other guy pulls his chute, all of a sudden that guy seems to shoot up. Well, it's not that. It's just that the guy with the camera is still falling. Think about when you're sitting in a car and you look over and there's an 18-wheeler beside you and he's inching forward and it looks like you're going backwards. You're not going backwards. It's just kind of a perception thing, okay? So when you describe the skydiver's motion, you're going to say that the skydiver slows down because the velocity is working, or the acceleration that's generated is working against his downward velocity. And that's good because you do want the skydiver to slow down. Okay, so there's your answer. Just remember that, pulling the chute kind of acts like a set of air brakes. He's able to slow himself down thanks to that parachute. But he's still going to be falling, just nice and slow so he can land safely. All right, that should do it for the Bubbas truck Bellwork.